Good day everyone. Today I'm going to talk about an exciting topic in geometry, which is geometric design. Geometric influences various aspects of our surroundings encompassing shape, line, volume, surface, area, curves, and other geometric elements. The impact of geometry extends to our daily lives, starting from our fascination with toys featuring shapes, patterns, and designs during infancy. The fascination with geometric shapes has mesmerized individuals in a range of disciplines, including art, science, engineering, and interior design throughout history. Mathematicians have meticulously crafted precise representations of these shapes and developed methods to calculate their measurements, including one-dimensional lengths, two-dimensional areas, and three-dimensional volumes. Now let's talk about three categories of geometric designs, which is polygons, solids, and non-polyhedra. So, polygons. A polygon is a flat shape with straight edges that exists in two dimensions. It can be categorized based on the number of sides it has. For example, a shape with 3 sides is known as a triangle, while a shape with 4 sides is called a quadrilateral. Additional examples include pentagons, hexagons, and heptagons. Polygons can fall into one of two categories, either simple or complex. A simple polygon possesses only one boundary and never intersects itself. In contrast, a complex polygon intersects itself at some point. Polygons can be classified as either concave or convex. A convex polygon is one in which all angles point outwards or away from the interior of the shape. To be more precise, the internal angles of a convex polygon cannot exceed 180 degrees. Conversely, if a polygon has any internal angles greater than 180 degrees, then it is considered concave. Now, solids. A solid is a representation of the geometry of three-dimensional space, which is the space we inhabit. It is referred to as three-dimensional or 3D because it has 3 dimensions: width, depth, and height. Solids possess properties that are specific to their three-dimensional nature, such as volume, the amount of space they occupy, analogous to how much water they could hold, and surface area, the area that would need to be painted if they were a physical object. The two primary classifications of solids are polyhedra and non-polyhedra. A polyhedron is a three-dimensional shape composed entirely of flat surfaces, each of which is a polygon. Examples of polyhedra include the platonic solids, prisms, and pyramids. Non-polyhedra, on the other hand, are solids that possess curved surface or a combination of both curved and flat surfaces. Examples of non-polyhedra shapes include spheres, cylinders, cones, and tori. A platonic solid is a type of convex polyhedron characterized by all of its faces being congruent, convex, regular polygons that do not intersect each other except at their edges, and having the same number of faces that meet at each vertex. There exist 5 platonic solids, which are tetrahedron, cube, hexahedron, dodecahedron, and isosahedron.
Tetrahedron is a three-dimensional shape that has 4 triangular faces. One of these triangles is considered as the base and the other 3 triangles together from the pyramid. This makes the tetrahedron a type of pyramid, which is a polyhedron with triangular faces connecting the base to a common point and a flat polygon base. Next is hexahedron. A hexahedron is a three-dimensional geometric figure that has 6 faces. The most common example of a hexahedron is a cube. which has 6 identical square faces. Each face is a quadrilateral, and the figure has 12 edges and 8 vertices. Third is octahedron. An octahedron is a three-dimensional geometric figure with 8 faces. In a regular octahedron, all the faces are equilateral triangles. It has 12 edges and 6 vertices. Fourth is the dodecahedron. A dodecahedron is a three-dimensional geometric figure that has 12 faces. In a regular dodecahedron, all the faces are regular pentagons. It has 30 edges and 20 vertices. Lastly, the fifth is the icosahedron. An icosahedron is a three-dimensional geometric figure that has 20 faces. In a regular icosahedron, all the faces are equilateral triangles. It has 30 edges and 12 vertices.
These four shapes, along with the tetrahedron, are the 5 Platonic solids. A Platonic solid is a regular convex polyhedron with congruent faces of regular polygons at the same number of faces meeting at each vertex.
Non-polyhedra. Examples of non-polyhedra is a sphere, a cylinder, torus, and cone. A sphere is a three-dimensional object that is perfectly round in shape. Unlike polyhedra, it is not considered a polyhedron because its surface is smooth and lacks any flat faces, edges, or vertices. The sphere exhibits complete symmetry with no distinguishing points, and all points on its surface are equidistant from the center. A cylinder is a solid three-dimensional object that consists of a curved surface and two parallel circles of equal size at its ends. The curved surface is formed by connecting corresponding points of the two circles with line segments. Due to its curved surface, a cylinder is not classified as a polyhedron. Torus is a solid formed by revolving a small circle along a line made by another circle. It has no edges or vertices, and therefore it is not a polyhedron. Cone is made by rotating a triangle. The triangle has to be a right-angled triangle, and it gets rotated around one of its two short sides. The side it rotates around is the axis of the cone. It has a flat base and has one curved side. Because it has a curved surface, it is not a polyhedron.
Here's another example of non-polyhedron. A torus is a surface of revolution generated by revolving a circle in three-dimensional space about an axis planar with circle. Number 2 is a sphere. Sphere is a perfectly symmetrical around its center with all points on the surface lying the same distance from the center point. 3 is a cylinder. Cylinder has two parallel congruent bases that are circular and one curved side. 4th is an ellipsoid. Is a surface that may be obtained from a sphere by deforming it by means of directional scalings or more generally of an affine transformation. And lastly is hemisphere. Hemisphere is a half of a sphere divided by a plane passing through the center of the sphere.
So that is all for today, and I hope you all learned a lot from my topic. And once again, I am Jerome Espejon, your instructor for today, and that is all. And